Okay, this video is covering 6.2, and we're basically building on what we did last time. In 6.1, we talked about how to find the area under a normal curve using the empirical rule. So remember, the empirical rule told us that, our normal curve has a mean right in the middle, and it said if you go one standard deviation right and one standard deviation left, remember that contains 68% of our data. If you were to go 2 standard deviations left and right, remember that right there contains 95% of all your data. And then the last one is if you went 3 standard deviations left and right. Remember that contains 99.7% of all your data. And we're interested in area under the curve because we learned that with a continuous distribution function, area under the curve is the probability of some event occurring. So what 6.2 does is it just builds on the same idea. It's just empirical rule only works for 1, 2, or 3 standard deviations left or right. So what if I want to know the area under the curve if I go 1.5 standard deviations left or right, or 2.7 standard deviations left? So to do this, we need to rely on a z-table or StatCrunch, and I'll show you how to do both. So here they just give a general breakdown of what we would be, or what are sort of the 4 common cases we'd be looking for. If we're on a normal curve, and I know I'm on a normal curve, because if they're using a z-score, they're talking about a standard normal curve. Standard normal distribution. Remember, that's where we have a mean of 0 and a standard deviation of 1. They don't even have to tell you that we're working with normally distributed data if they're using a z-score. By default, this is the distribution we're dealing with. So basically, here are the scenarios. We maybe want to be looking for all z-scores left of some number a. So again, if you think about it, we've got our mean right in the middle, okay? And then you've got a bunch of standard deviations to the right and to the left. And maybe a is just some number. Maybe it's like 1.5, or let's say negative 1.5. And I'm looking for the area what's the probability of getting a z-score less than that number. Remember, probability is area under the curve. So I would be looking for that area there, if that was A. It could be that I'm looking for the area right of that number A. I want to know what's the probability of getting a z-score bigger than A. So that's any of these z-scores here. Probability would be the area under the curve. So again, it's just like what we did in 6.1. We're looking for the area under the curve, but in 6.1 we only dealt with 1, 2, 3, or negative 1, negative 2, or 3 standard deviations. We didn't have to deal with like 1.3 or 1.9. So to do that, again, we need StatCrunch or a z-table. Another thing we might do is we might be looking in between 2 data values, or z-scores, I'm sorry. So maybe I want to look for the probability, which means the area under the curve for all the z-scores between A and B. So in that case, you'd be looking at this area in between those things. That's sometimes something we're interested in. Or it could be that I'm interested in looking for the probability of finding z-scores left of some number negative A and right of some number positive A. That's what this stuff is telling us. Okay, and one thing we have in this case is that these 2 things have equal area. And that's because we know that the normal curve, the bell-shaped curve, is symmetric. So one trick we'll use later is if you just find one of these areas, you just double it up to get the 2 of them combined. Okay, so if we scroll down, this tells us how to find the area using a z-table. I think it's way easier if you just get your hands on some problems and practice it and see how it works, because it's fairly confusing to read this. These are the right steps, but it's just hard to kind of read it and go do it. So we'll just do some examples, and I think that'll make a lot more sense. We're also going to do it on StatCrunch, which is really easy to do. And I'm not going to show you how to do it on a calculator, because different calculators do it differently. I'm not sure which you have. I'm happy to help with that in office hours or something if you're interested, but we're going to do z-table and on StatCrunch. Okay, so let's take a look at this one. It says, find the probability of finding a z-score less than 1. So again, they don't have to tell me that I'm on a normal distribution. It's a standard normal distribution by the very fact that they are referring to z-scores. Remember, when we look at the z-scores, they are normally distributed, and they follow the standard normal distribution where you've got a mean of 0 and a standard deviation of 1. So I've got a mean right here of 0, and they said I want to find all the z-scores less than 1. So there would be a z-score of 1, right? Because if you remember, a z-score, the way we actually find it is it's a data value minus the mean over the standard deviation. It tells us how many standard deviations we are from the mean. We've looked at data where we've had data be, 2 standard deviations away from the mean, 3 standard deviations away from the mean. But we can fine tune it. A z-score tells us exactly how many standard deviations we are from the mean. So they're asking me to find the probability, which means the area under the curve, of all these z-scores that appear left of 1. So that would be all of these guys here. Okay, all of those guys there. And this you can actually do by empirical rule, because it's a whole number. Empirical rule tells us how to deal with standard deviations of 1, 2, or 3. Don't we know by empirical rule that if I went 1 standard deviation left and right, that would be 68%. And so we learned in the last video that if you just went 1 to the right, or one-sided there, that area has to be 34%. And all of this area, because all of this is halfway, it's just all the chunk left of the mean, we know that there is 50%. So in total, the total area left of a z-score of 1 is 50 and 34, that's 84%. And again, right now, there's no context to what the heck we're going to use this for. So I understand this may seem very far out there, and just kind of like, what the heck do we need this for? This is how we're going to calculate probability of continuous random variables. Remember, for a continuous random variable, we can't add up all the probabilities because there's infinitely many. So we think of it as area under the curve. We talked about that in a video following 4.3. This is our tool, or the mechanism for finding area under the curve, either StatCrunch or a z-table. So right here, we could not do with empirical rule. I couldn't do it because empirical rule, again, only deals with whole number standard deviations. So this is saying find the area under the curve that is, or left of a standard deviation of 1.5. So again, I've got a mean at 0 because I am on a standard normal distribution because we're talking z-scores. I know to the right is positive z-scores and to the left is negative z-scores, aka standard deviations, right? Don't forget, this is just saying 1.5 standard deviations, and because it's positive, it's above or to the right of the mean. So if there's 1 standard deviation, maybe there's 1.5 standard deviations. And I'm interested in getting the probability, so the area under the curve, of getting a z-score less than 1.5. So to the left of that. That's the area I'm interested in. Okay. So empirical rule will not work because it doesn't tell us how to handle a standard deviation of 1.5, so we could rely on a z-table. Let me pull that up for you real quick. On a z-table, there's generally two types we see. Let me get this one. So again, when you've got a standard normal curve, the mean 0 is right in the middle, and you've got positive z-scores to the left, to the right, and you got negative z-scores left of that. Now, one thing to make sure you're aware of is that most z-tables, when you find your z-score, and that's what these are the z-scores, and I'll show you how to read them in just a second, and these are the areas under the curve. Most z-tables are telling you the area to the left of that particular z-score. Okay, that's sort of the default, the area left of that particular z-score. So when I was doing that last problem and it said find the probability of getting a z-score less than 1.5. Well, this isn't the correct table I would use, because this is telling me the probability or area under the curve for negative z-scores. So all of these z-scores, and I'll show you how to read them in a second, but if you notice, these z-scores are all negative. Okay? So this isn't the table I want. The table I want is on the next page, which this is telling me the area under the curve for positive z-scores, which is what I've got. So again, I'm looking for the probability that z is less than 1.5. So if I were to think of that visually, again, the mean would be right here, and a z-score of 1.5 would be above the mean, because it's 1.5 standard deviations. It's positive, so it's to the right of the mean. And because I'm looking for the z-scores less than that, I want all the area to the left of that, which is good because that's exactly what my table shows, areas that are to the left of your chosen z-score. So all I need to do is I need to find this z-score and read the area. So if you look down here, look for a z-score of 1.5. 1.50. So here's 1.5. Okay, and if you need to fine-tune that, that's how you go down this list. So say I wanted the number 1.59, I would go 1.5 and all the way down to the 0.09, and I would see where they meet. 1.5 is like 1.50, so I want 1.50. So right there, that number 0.93 or 933 is the area that I would find to the left of a standard deviation of 1.5 or a z-score of 1.5. So this area is 0.9332. That area is the same thing as probability. Area under the curve is probability. So that answer right there would be 0.9332. All right. If you just notice real quick, remember the one we did right before? We looked at the probability of getting z to be less than 1, and I think we found that to be 84%, right? Using empirical rule. If you find a z-score of positive 1, actually the area to the left of that is 0.8413. It's actually 84.13%. Remember, empirical rule is an approximation. Z-tables are a little bit more accurate, okay? So the next page is just a whole lot of these and practicing all the variations that come our way. All right, so let's go back to the notes and take a look at those. Let me fill this one in. We said that this came out to, what did this come out to? The probability that z was less than 1.5 was 0.9332, I believe. That is the area left of that z-score. And again, what this z-score means is this z-score represents some data value that is 1.5 standard deviations from the mean. So maybe it's an exam score that's 1.5 standard deviations above the class average, okay? And this would then be the probability of getting anybody less than that score, to the left of that score. So again, we're going to actually put this to use in a little bit. In the very beginning, they just have us practice a whole lot of just finding these values. But towards the end of this video, or actually after this next page, we'll start to actually use it, okay? The next page has a whole lot of scenarios where we practice this out. So I'm going to do some of each type using the z-table, and then I think just to make things faster, I'm going to also do some using StatCrunch. I want to show you both, but let me just go ahead and do one or two of these. So let's find this one, the probability that z is less than or equal to -1.5. The fact that it's z tells me we are on a standard normal curve. So my mean would be 0. Since that z-score is negative, I'm talking about some data value that is 1.53 standard deviations below the mean. So there's -1.53. And I want the probability, area under the curve, of something that is left of that. I want z-scores that are smaller than -1.53. So I want area to the left there. That's always convenient because that's exactly what our z-tables tell us, area to the left. So now I need to go consult a z-table to figure this out. It's a negative z-score, so I need to look at the negative z-table. By the way, I should have said in the beginning of these videos, these z-tables are going to be posted on Canvas, so you'll have access to them. Let me erase all this stuff since we don't need it now. Oh, I'm still on the page for the positive z-scores. I need the negative z-scores, so I got to scroll up to that one. All right, this table tells me how to deal with negative z-scores. Okay, so again, I'm looking for there's the mean of 0. I'm looking for the area to the left of a z-score of -1.53. I want that area right there. All right, so find that z-score. So let's go down till we see -1.5. Let's try this. Okay, there's -1.5. I want -1.53. Scroll up just a little. Can I fit it? Yeah, I want -1.53. So I'm going to go over to the 0.03. And where they meet, this is -1.50, -1.51, -1.52, and -1.53. Again, I'm reading those values. That number right there is the area to the left of that z-score. So this area is 0.063, okay, 0. All right, and that area is the probability of getting any data value to be more standard deviations to the left than -1.53. So let's go back to the notes and fill that in. This was 0.063, or 6.3% chance to be left of that. Let's go ahead and try this next one. The probability of getting a z-score to the left of -2.71. -2.71 is very far to the left, right? That's -2.71 standard deviations below the mean, or 2.71 standard deviations below the mean. So, and because I want a z-score to be less than that, I'm looking for the probability of, or the area that is left of that. So it should be a smaller number than this. It's less area, so therefore should be less probability. So let's go see. Back to the negative z table. Erase all this work. I'm looking for the probability that z is less than negative 2.73, I think it said. So find this z-score. So go down and look for negative 2.7. There it is. 3 would be right there, right? Where the negative 2.7 and the 0.3 combine, that's the area to the left of negative 2.73. 0.0032. Let me go back. Oh, dang it. It was a 7.1. Hold on. 7.1 is actually here. 0.0034. .0034. So this would actually be a 0.34% chance of getting a data value that is further to the left than whatever data value gives you this z-score. So in other words, getting a data value that is more than 2.71 standard deviations below the mean. Okay, which we knew it should be less. I mean, this was 6.3%. This was further left, less area, so we knew it should be a lower probability. So I hope you're getting the idea. Let's try one or two of these. Now, here what they've done is they've changed things up on us, and now they're asking for z-scores greater than a particular, they're asking for the probability of getting a z-score greater than a particular number. So if you were to draw this out, standard normal curve, mean is 0, and find a z-score of 0.5, so half a standard deviation above the mean. Now this time they want the probability, so the area under the curve, of finding a z-score bigger than this thing. So we're looking for the probability of getting data values that would be more than 0.5 standard deviations above the mean. This is a little bit of a pain because remember your z-tables only tell you left area. But the one thing you know is you know that all together the whole area under your curve should add up to what? The whole thing should be 100%, right? So if you were interested in just some area to the right of some number, okay, the way you figure this out is you consult your z-table and it's going to tell you this area. It always tells you left area. Okay, so we can find this. Whatever that is, you take 100% minus this thing. Right? So let's put it to practice and see. Okay, so I've got a positive z-score, so I need to look at the positive z-table. So not the negative one, I got to go down to the positive z-table. I need z-scores that are to the right of the mean. There's the mean. So again, I want z-scores that are to the right. I'm looking for the probability that z is greater than 0.5. So first let's find this spot. Let's find half a standard deviation. So there is 0.5 and I just need 0.50. It's dead on. Okay, but remember this is telling me area to the left. So what I figured out is that the area to the left of my z-score of 0.5, all this area here is this. This whole area here is 0.6915. Well, I want the area to the right of that. I want this area. But all I need to do is, again, recognize that, well, the whole thing, all the area to combine is 100%. So let's take 100%, or 1, and let's subtract out what I don't want. I don't want this. I just want to be left with the green. So I'm going to subtract all that area away. And you would get 0.3085. 0.3085. That is this green shaded area here to the right of a z-score of 0.5. 0.3085. So this was 0.3085. This can be a little confusing at first, but you do this a bit and you get the hang of it real quick. Let me skip this example. I'll do some of these with StatCrunch to show you that that's a lot nicer. So let's jump over to this example. Again, I want the probability. I've got a z-score, so standard normal curve, mean of 0. Now this time my z-score is negative 1.23, so it's negative, so it's left of the mean. But again, I'm interested in getting the probability of finding z-scores larger than that. So to the right of that number is what I'm interested in. Again, sort of annoying because my z-tables don't tell me that. My z-tables are going to tell you this left area here. And that's all right, we'll do the same little process. This time I've got a negative z-score, so let's go to the negative z-table. Okay, so I gotta scroll up to my negative z-table. All right, that's what I want. They asked for the probability that z is greater than negative 1 point, I forgot already, 43 maybe? 23. 1.23, okay? So if I were to visualize it, and by the way, I would really encourage drawing these graphs. I should have mentioned that in the beginning. Draw the picture every time, especially in the beginning, because it really helps with these funky cases, learning if you should, subtract it all from 100% or what. So there's a z-score of negative 1.23. I want probability, so I want area under the curve, and I'm looking for the probability of getting a z-score larger than that. So again, it's everybody to the right. Don't forget, your z's table tells you the left area here. So let's find where this is on the z-table, negative 1.23. There's negative 1.2, negative 1.20, 0.21, 0.22, and 0.23, right? So this is what I'm interested in right there. That is the area to the left of the z-score we have, 0.1093. So this area here is 0.1093. Well, again, I don't want that area. I want this area highlighted in yellow. This area, again, to find it, we know everything is 100% or 1.0. And all I need to do is I need to just subtract away this bit, which I do not want. So I'm going to subtract out 0.1093. Oops, 1 minus 0.1093. So that's 0.8907. That would be all this highlighted yellow space, and that's the probability of getting a z-score larger than negative 23. .07, I think, if I'm remembering. I really hope, if you haven't started yet, you should be pausing these, at least at this point, and try them on your own, and then see what I get, okay? So definitely do that with these two. Pause it, try them using the z-tables or StatCrunch, and then double check. I just want to do one of these by hand, and then I'm just going to probably do the rest with StatCrunch. We'll see. Maybe I'll show you one more by hand, and then we'll do StatCrunch. Let's do this guy. Now this guy, what this is saying is, it's saying, okay, I've got on a standard normal curve with a mean of 0, because it's standard normal. We're talking z-scores. Now I'm looking for an area in between two z-scores. I've got a z-score of negative 2.41 and a z-score of 1.03, and I want to be in between the two of them. I want to know what's the probability of getting data values that are in that window of standard deviations from the mean. Well, again, my z-table only tells me area to the left, so what I could do is I could find the area from here left using a z-table, and I could find the area from here left using a z-table. Now what I'm interested in is only this area right here, but I could take the area left of 1.03 and then cross out this area which I don't want, okay, which I could just read off a z-table. So let's try that. Let me go down to the z-tables again. Now this one I'm going to need positive and negative z-tables, so this is going to be fun. So let me erase all this work. Draw the same picture. Okay, I had a z-score of negative 2.41 and then a z-score of 1.03, and I wanted the area in between the two of them. And again, my approach was going to be, well, I can find this whole area here to the left of negative 1.03. I could do that on a positive z-table, and I could find this area here to the left of negative 2.41. If I just cross out that area, subtract it away, I will be left with just the area I'm looking for, just the yellow part. So let's start by finding the area left of negative 2.41 and left of 1.03. I've got a negative z-table pulled up, so let's find the area left of negative 2.41. So there's negative 2.4 and 1 right there. This area here is 0.08. Nope, I need one more zero there. 0.008. Okay, that is this area here that I'm trying to get rid of. So let me see if I can make this a little better. From here to the left is 0.008. Okay, now let me go to my positive z-table and find the area left of 1.03. So I think that was, nope, that's down here. 1.03 would be, there's 1.0, 1.00, 1.01, 1.02, there's 1.03, 0.8485. So this area from here is 0.8485. Now all I want is this yellow part in between them. So if I just take this 0.8485 and I subtract this part, which I do not want, which I know is that, I subtract 0.008, I'll be left with just the area of the yellow highlighted region. 0.8485 minus 0.008 is 0.8405. I guess I could have done that. 0.8405. That's the probability, 84.05%. That's the probability of landing in that yellow highlighted region. Let's see here. So this is 0.8405. Okay? So again, please practice these. Pause the video and practice those if you haven't. I'm going to do those on StatCrunch, but before I do that, let me just go ahead and do one of these last ones. It's a lot of examples on here. Let's see. Let's set these two up, and again, we'll just run them with StatCrunch. Here it says find the probability of obtaining a value that is 1.25 standard deviations away from the mean. 1.25 standard deviations away from the mean. Another way they could say that is like this. Because really what's going on is the distance is, that's what absolute values is. It is distance, right? So if I want to find the distance from the mean being 1.25, I want to say the distance here is less than 1.25. What it means is, now if you recall from algebra, the way you break this thing up, when your absolute value is less than some number, your z-score is sandwiched in between positive 1.25 and negative 1.25. Those are algebraically equivalent to one another. So finding the probability of getting a value that is 1.25 standard deviations away from the mean, that means it could be away on the positive side or away on the negative side. Right? It's saying that if I go 1.25 above and 1.25 below, I'm trying to be in between those guys. Those would be all the data values that are within 1.2 standard deviations from the mean. Okay. Once you get the picture drawn, to do it's not that bad. You're just going to use similar techniques there. Same with this problem. Let's just set it up. I've got the absolute value being less than 1.64. So what I'm saying is the z-score is sandwiched in between 1.64 and negative 1.64. Oops. 1 second, I'm missing a symbol that I could barely fit them in there. These are algebraically equivalent. So if you need some help remembering that, hit me up in office hours and we can go over those cases, all right, or in class. But again, what we're looking at here is I've got a z-score, or my mean is 0. I've got z-scores at 1.64 and negative 1.64, and I'm trying to be in between them. And so again, I'll use techniques similar to what we did here to find the area in between two z-scores. I'll run these on StatCrunch to get these numbers. The last one I'll do by hand. I'll do one of these by hand, and then we'll jump onto StatCrunch to try these. Here, they're talking about not being in between two numbers. They're talking about being outside of two numbers. So if you visualize what's going on here, they're saying, what's the probability of finding a z-score left of negative 0.5 and right of 0.5? So there's negative 0.5 and positive 0.5. I'm looking for z-scores that are smaller than that. So that would be to the left. But I'm looking for z-scores that are larger than positive 0.5. So that would be to the right. So here I'm not looking for the area in between them. I'm looking for the area outside those two numbers. And you really could do this a couple ways. But the easiest way is to recognize that this area and this area are the same by symmetry. By symmetry of the normal curve, this space here is the exact same amount of this space here. This would be relatively easy to find on your z-table because it tells you left areas. So all I'm going to do is, and this is what they tell you on the previous page, is that really what you could do is to find this. What I really could do is I could just double up the area that is left of negative 0.5. I could just find this area here and double it. And that's going to go ahead and give me the combined area of those two arms. And again, this I can consult the z-table. It's a negative z-score, so find the negative z-table. And I'm looking for a score of negative 0.5. Well, there's negative 0.50. That would be it. So 0.3085. let's see, 0.3085. So this would be 0.3. And I'm going to double that up. So I should get 0.617. That would be this total probability here, the total combined area under the curve of numbers left of this z-score or right of this z-score. And again, what we're talking about is data values that are this many standard deviations from the mean, because that's what a z-score is. It's the number of standard deviations you are from the mean. Again, I know right now you might be feeling like, what the heck am I doing this for? Like, we just have no idea why we're doing this, but this is how we'll calculate probability. And in an example or two, we're going to actually put a real life example to it. Let me fill some of these in I didn't do using StatCrunch. So if you use StatCrunch, boy, it makes life easier on some of these things. So I already have it loaded, I think. Now, remember, if we're calculating probability, we go to Stat, Calculators, and based on the type of distribution you're working with, you would find the correct distribution and use the calculator, like we previously did custom and binomial. Well, now we're talking about normal. And again, they didn't even have to tell me the fact that they're using z-scores. That means you're on a standard normal distribution. So I want the normal calculator. There's my bell-shaped curve. This one is standardized because it's got a mean of 0 and a standard deviation of 1. One of the things we'll see later is that if I'm using StatCrunch, I don't have to standardize these things. That's only if you're using a z-table. Z-scores must be, or the z-scores are referring to a standard normal curve where you have a mean of 0 and a standard deviation of 1. Let me look back at some of these I wanted to do. I wanted to find the probability that z was greater than 1.11. Okay, well, watch how easy this is on StatCrunch. Where'd you go? I'm going to say that I want the probability of getting a data value. They say x, but we can think of it as z greater than 1.11. There's the probability, 0.1335 if I round it to. Don't get hung up on the fact that this has greater than or equal to, whereas on our notes it has only greater than or less than. Remember, technically, we don't talk about the area exactly at 1.11. If you were only looking at the probability of getting exactly dead on 1.11, it's essentially zero probability because there's infinitely many numbers here. There's infinitely many numbers. So the possibility of getting 1 out of infinity is basically 0. 1 divided by infinity would be 0. So whether or not your book or notation uses greater than or equal versus greater than doesn't matter. Anyways, that's the answer. 0.1335 if I round it. So I'm going to add that in. This is 0.1335, and I'll just say that was StatCrunch. Let's do this one. I want probability of getting a z-score greater than negative 3.1. Go back here. Again, don't get alarmed that that's x. These are z-scores I'm typing in because I'm on a standard normal curve. And I know it's standard normal because I got a mean of 0 and a standard deviation of 1. I want the probability of being, oops, I already forgot. Right or greater than negative 3.1. Greater than negative 3.1. There it is, 0.9990. StatCrunch. So much more convenient than a z-table. StatCrunch also does these in-between ones. So again, if you think of what's going on here, the mean is 0, and that's exactly where a z-score of 0 would be, because z-score of 0 means that you are 0 standard deviations from the mean, so you're right on the mean. I want to be sandwiched in between that and a score that has that is 0.75 standard deviations above the mean. I'm looking to be in that window there. Okay, I don't have to mess with any of this subtracting stuff. On StatCrunch, there's an in-between feature. So I just hit between, and notice now the calculator is calculating area between two numbers. You just tell it what two numbers you want to be in between. I want to be in between 0 and 0.75. There's the area. It does it for you. 0.2734. 0.2734. Very nice. Let's scroll down to, let's see. Might as well get all these answers here. So this I want to be in between negative 1.64 and positive 1.64. So in between negative 1.64 and a positive 1.64. Oops. What did I do? Oh, it doesn't like that bracket in there. Okay. 0.5146 is my area. Oh, wait a minute. Look at that. I put 0.164. That's wrong. I want 1.64. What caught my eye was the graph. These are supposed to be the same numbers, so the graph should look very symmetric. It doesn't look symmetric. It looks like it's favoring the right side here. So that's what caught my eye. This should be 1.64. Do you notice now it's much more symmetric? Goes equal distance from the mean. That's 0.899. Let's round it to 0.899. And let's go ahead and do this last one here. Here I've got a mean of 0, and this time they're telling me to be left of that z-score or right of that z-score. So I want to be left of negative 2.2, just negative 2.2. I want that area, and I want the area to the right of 2.2. Okay, I'm looking for that combined area there. You could do this two ways on StatCrunch. One way is I can find, StatCrunch has the in-between feature, so I could find the area in between them. And since I know together the blue and the yellow make 100%, I can just take 100% or 1 and minus what I find in between them, minus the yellow part. Or I could do kind of what I did over here. I could just find the area to the left of this guy and double it up. So it doesn't really matter. I'll just do that. I'll take the area, I'll go back to standard. I'll find the area less than negative 2.2. So that's 0.139. So I'm going to say that hold on, switch pens for me here. The probability of z being less than that or greater than that is the same as twice the probability of just being less than negative 2.2, which was twice 0.0139, which, where'd the calculator go? Is 0.0278. That's the probability of landing in that region. Okay. All right. Again, big deal. You might be finding like, okay, what the heck am I going to use this for? Well, let's do a problem and see. All right. So let's see where we actually need this skill. So if you're going to calculate probability for something that is normally distributed, again, knowing the distribution tells you how to calculate probability. If it was binomial, we use the binomial probability formula, right? If it was uniform, we learned how to find the area under the curve there. It was like the area of a rectangle. If it's normal, you find the area under the curve using StatCrunch. Or if you're not going to use StatCrunch, then what you're going to have to do is you're going to have to convert your normal distribution into the standard normal distribution. Convert your normal distributions into the standard normal distribution by converting your data scores into z-scores, okay? So you're going to find the z-score for your data values and then use a z-table. All right, so you got two options. One, use StatCrunch. And then there's no converting necessary because you saw in StatCrunch, it'll accept any mean and standard deviation you want. It doesn't have to be standard. That's just kind of the default. And I'll show you how to do this. Two, if you want to calculate some probability of a normal distribution, you're going to have to convert to the standard normal distribution by finding the z-scores for your data values. Then use the table, a z-table. So we'll do this problem both ways. Okay, so this says the distribution of scores on a recent math test were normally distributed. Again, we have to know the type of distribution to know what formula to use. So it says there was a mean of 68 and a standard deviation of 5.5. The professor stated that a score of 60 is the minimum in order to pass. What percentage of students passed that test? So if we think about it, I'll just kind of draw it off to the side. What's going on here is it's normally distributed, so it's bell-shaped. The mean is 68. And then I have every standard deviation that I go to the left or right. A standard deviation, one standard deviation is 5.5 points. So if I go above or below the mean, a standard deviation, that's how much I go. The professor stated that a score of 60 is the minimum needed to pass. So if there's a score of 68, 60 would be something to the left of that. There's our score of 60. And in order to pass the class, you have to get a minimum of 60, meaning you need to be 60 or above. You need to be in this yellow shaded region. Right? Anybody that scores here to the right of 60 is going to pass that test. Okay. Well, I can't use empirical rule because if you think about it, the distance here is 8, right? This is 8 class points or test points below the mean. That's not a whole number of standard deviations. That's kind of like 1.5 standard deviations or something. So what I need to do is I need to either use StatCrunch or I needed to convert this to a standard normal distribution and use a z-table. Let's do StatCrunch first because that's going to be the easiest. So if I go to StatCrunch, and just to remind you, I'll close this out. Again, what you do is you go to Stat, Calculator, because we're calculating probability, find the type of distribution you're working with, which is normal. Tell it the mean you have. Our test scores were had a mean of 68, and the standard deviation for our test scores was 5.5. And I'm trying to find the probability of getting data values greater than 60. Right? That looks like our picture, right? We want to know what's the probability of being greater than 60. All right? All these people passed. Well, that ends up being 0.9271. And go fill that in. According to StatCrunch, that is 0.9271. So that right there is the percentage of students that passed the test, right? The percentage of students that passed the test is 0.9271. It's really quick if you're using StatCrunch. If you're not using StatCrunch, you first have to convert these to z-scores. You can't look at your z-table and look for these numbers because these are not z-scores. Those are raw data value scores. So what you would need to do first, if you want to do using a z-table, we have to first convert to z-scores, or convert to standard normal curve by working with z-scores. So for the data value of 60, I need to know what is that z-score if I'm going to use my z-tables. So remember, to find a z-score, just kind of remember, z-score is always your data value minus the mean over your standard deviation. So for this case, my z-score would be a data value of 60 is the data value I'm interested in. The mean was 68 and the standard deviation was 5.5. Let's see what that is. That is negative 1.45. So a score of 60 is 1.45 standard deviations below the mean. And so now this becomes a problem like we were just doing. It's now standardized because I'm talking about z-scores. And I've got a z-score of negative 1.45, and I want the area to the right of that thing. Again, that's kind of a bummer because my z-tables don't tell me area to the right. They tell me area to the left. But if I find that, I know the whole thing is 100%. I could subtract that out. So let's find the area here. According to my z-table, I'll be able to get that. If I go to the z-table, and I've got a negative z-score, so I need to find the negative z-table. There I am. And I'm looking for a z-score of negative 1.45. So there's negative 1.4. Negative 1.45 would be right there, right? Negative 1.45. That's the area left of that z-score, 0.0735. Oops, wait a minute. So this area here was 0.0735. That's the area left of that z-score. Now I want the green area, so we know the green area, the area right of that z-score would be 100% or 1 minus the area you don't want. I do not want that area under the curve. So that comes out to 0.9265. That's what we think would be the probability of getting a z-score higher than this, and therefore the probability of passing the class, or the percentage of people that pass the class. And if you compare it to what we found with StatCrunch, it's pretty close. All right? StatCrunch is actually a little more accurate, but ours is pretty darn close. So the percentage that pass the class is approximately 92.7%. I'll just round that to 92.7% of the class passed the test. Okay. Okay, let's try the next set of examples. Or the next example. So this says that this is example 9. Here's what they've done. First of all, they didn't tell us this here, but one thing we'll learn is that heights of people are normally distributed. If you were to go and poll a whole bunch of people and find their heights and map out those heights, you're going to get something that looks like this. There's an overwhelming common height, And then there's fewer people shorter and fewer people taller than that average height, and they follow a normal distribution. So they've given us the mean height for men and the standard deviation height for men. These must be in inches. They've given me the mean height for women in inches and the standard deviation of that data in inches. And then they say that the U.S. Navy requires that fighter pilots have heights in between 62 and 78 inches. They ask us to find the percentage of women that meet that height requirement. Okay, so I kind of really need to see the picture going to get an idea of what's going on here. We're talking about women, so I'm going to draw the normal curve for the women's height. The mean for women is 63.8. Now the Navy says that if you want to be a fighter pilot, you've got to be in between 62 and 78 inches. So 62 would be a little bit below the mean, and 78 would be fairly high above that mean. And so this percentage of women would satisfy the Navy's height requirements to become a fighter pilot. Okay, so we want to find that percentage, the percentage of women or the probability that a woman fits that height requirement. So I've got two options. One, and the easiest one, is use StatCrunch, because you saw that that could quickly tell you the area in between two data values, or two z-scores if you're working with the standard normal curve. If you're not going to use StatCrunch, then what you need to do is you need to convert this to the standard normal curve. You would need to find the z-score for this guy and the z-score for this guy. You got to find the z-score for this and the z-score for this, which isn't bad. Remember, z-score would be, watch, we could do it for this first one. Data value minus mean over standard deviation. So for this first one, your data value is 62, the mean is 63.8, and the standard deviation for women was 2.6. So 62 minus 63.8 divided by 2.6 is a z-score of negative 0.69. Okay, so that's this z-score, 0.69. Negative 0.69. Doing the same exact thing, you could find the z-score for 78. Okay, and once you have those two z-scores, we already did problems like that a page or two back, where you find the area in between things using the z-table. So it's doable. It's just so much easier with StatCrunch. Because if, again, I'm just going to do it that way. If I go to StatCrunch, and if you do it with z-tables, we won't get the exact same answers, but we'll be close. I already have the standard normal curve up. I'm going to go in between. Now I got to adjust my mean and standard deviation. For this one, the mean of height of the women was 63.8. Their standard deviation was 2.6. And I'm trying to find the percentage of women that are in between 62 inches and 78 inches. So there it is, 0.756 if I round it to. 0.756% of women would meet the Navy's height requirement to be a fighter pilot. So on StatCrunch, the probability of getting some data value, and notice I'm not using a z because it's not a z-score. I'm using data values, 62 and 78. That was, what was it? 0.756. So 75.6%. Okay. Let's do the same thing for men. So that's what it says. Find the percentage of men that meet the height requirement. So if I draw the normal curve showing the heights of men, men have a mean height of 69.5, it says. 69.5 inches is the mean height for men. So again, the Navy requires that we're between 62 and 78. So 62 would be a little more to the left, 78. And this is the area I'm interested in. So again, you got two options. StatCrunch, which is what I want to do. I want to use StatCrunch and find the probability of getting the height of some male to be in between 78 and 62 based on that mean and standard deviation. Or what you need to do is you need to convert each of these data values into z-scores, and they're going to be different z-scores because you now have a different mean and a different standard deviation. So you're not going to get the same z-score you got for women. This will be a different z-score here. Okay, so that's the other option, is you can convert them to their z-scores and then find the area in between them. Since I've got StatCrunch up, well, let me just show you one of the conversions. I don't want to do it that way because it's a pain in the butt. But if you do convert them to z-scores, again, you're on a standard normal curve now. And let's see what 62 would end up being based on this mean and standard deviation. For 62, if I take the data value minus the mean, which is that for men, over the standard deviation, I get negative 3.13 if I round it to it, or round it to the decimal there. So again, a very different z-score because we have a very different mean and standard deviation. You would then need to go find the z-score for 78, and then using your tables find the area in between them. So it's totally doable, but let's do it faster with StatCrunch, because then I don't have to normalize or standardize anything. I can use any mean I want. For men, the mean was 69.5, and the standard deviation was 2.4. And I'm interested in the same bounds, finding someone with a height between 62 and 78 inches. And that's 99.9% of men fall in that category. So this would be 99.9% of men meet the height requirements to be a fighter pilot, whereas only 75.6% of women meet the height requirements to be a fighter pilot. All right, so that's not really fair. Okay, let's take a look at one last topic. This is a long section, guys. Hang in there. One last topic, and then, okay, so here's the idea. What we've been doing this whole time is we've been either giving z-scores or data values, and we've been asking you to find the area to the left of them, right of them, in between them, or whatever. Okay, but we've always given you the data value or the z-score and asked for the area. We could do that the other way around. We could say, here's the area. You tell me what's the z-score or what's the data value. That's known as doing an inverse, right? Or talking about an inverse normal. So we're doing it backwards. Again, here they're going to give us the area, and we are going to have to find the score. As far as a z-table goes, that's really no big deal. To do it on a z-table, it just means that instead of looking at starting with the score and looking for the area, you're going to do it the other way around. You're going to find the area you want, and then you're going to go read the score that it belongs to. So it's just again turning it around. And StatCrunch, again, it makes it much easier to do. But let's take a look at the notes. Where were we? No. Oh yeah, I think we are on that next page because I don't think there's anything to do here. So what they're describing here is kind of like on the first page when it talked about finding the areas. It sort of breaks down case by case how to do this by hand. And by all means read through it, but I think it is just easier once you get your hands on an example and see how it works. So again, this was the last case here. You could read through the steps on how to do it. StatCrunch is going to be a heck of a lot easier. And again, I'm not going to show you on the calculator unless you want to. Ask me and I'll show you how to do it. But everyone's calculator works a little different. So let's actually try an example and see that it's not that bad. Example 10 is find the z-score that cuts off the lowest 10% of a normal population. So I've got a normal population and I'm looking for a score that cuts off the lowest 10%. The lowest 10% would be down here, right? Because again, the mean gives me 50%. The lowest 10%, so that would be somewhere left of the mean. So let's just say right there, let's say that's 10% of the area under the curve. Let's say that's 0.10, 10%. I'm looking for that z-score. Okay. So again, it's a little different than what we've been doing. Last time they gave us the z-score, we told them the area. Now they're giving me the area, and I need to find the z-score. Well, wouldn't this z-score be negative because it's left of the mean? So let's consult a negative z table. So let's go back to the z table. There's my negative z table. Now here's the challenge. I have to find 10% in this list. Sometimes, in fact, rarely is it right on. You have to go to what's closest. Sometimes it's right in between two numbers, and so you could average their z-scores, kind of split down the middle. So I need to look for as close as I can get to 0.10. So here I'm coming up to it somewhere. There's 0.1003. And there's 0.0985. So would you agree that those are the closest areas I can get to 0.10? In fact, an area of 0.10 would be somewhere in between those two, right? In between 0.1003 and 0.0985. So therefore my z-score, if I come over here, is negative 1.2. And it's in between those. It's like maybe it's not quite negative 1.28. It's not 1.209. It's in between them. So maybe it's negative 1.285, right? That would be in between negative 1.28 and negative 1.29. So you can go with that. You can just try and get as close as you can. That's what I would do on the table here. So let's go back to the notes. I think this page. Yeah. So my best guess is that this z-score here is negative 1.285. Okay. That z-score would cut off the lower 10%. Let's see what StatCrunch says. StatCrunch. Nice thing about StatCrunch. Now, I'm talking about z-scores, right? Z-scores. So that means that this is not only just a normal curve, it is the standard normal curve. So that means I need to plug in a mean of 0 and a standard deviation of 1 onto my calculator. Mean 0, standard deviation 1. Now these numbers here are z-scores. I don't want in between. I want the standard. I'm looking for the area left of some number. I don't know what the number is, but I know what the area is. I know the area is 0.10, 10%. All you gotta do is hit compute and it's gonna fill in the number. They say it's really negative 1.281 or 2. I said negative 2, what did I say? Negative 1.285. They say it's negative 1.282. That's okay. So, or z equals negative 1.282 according to StatCrunch. Again, StatCrunch is more accurate than those z-tables, but the z-tables do a pretty darn good job. Okay. Let's try this next one. Okay, find the z-score that cuts off the highest 5%. So again, I'm on a standard normal curve because they're talking z-scores. This time I'm trying to cut off the highest 5%. The highest 5% would occur out here. That's my highest 5%. right? 0.05. They're asking me for that z-score. Now, if I'm going to do this one with the z-table, remember, my z-tables only tell me left area. My z-table only is capable of telling me the area to the left of some number. So if 5% is the area to the right of the z-score, what's the area to the left of that z-score? If that's 5%, wouldn't all this be 95% or 0.95? So, because my z-table only tells me left area, if I want to find this z-score, first of all, I would use the positive z-table, right? Because I'm to the right of the mean. And then I would need to look for an area of 0.95 to find that z-score. Okay, let's try that. Let's find this positive z-table. That's the negative one. There's the positive one. And I'm looking for an area, so I'm looking in this part, an area of 0.95, because again, I'm looking for the 0.95 to the left of my z-score, which would leave 0.05 to the right, the highest 5%. So since this tells me left area, let's find a left area of 95%. Look, it's right in between these. 0.9 or 0.9495 and 0.9505. 0.95 would be right in between those two things. So I think we're looking at a z-score of 1.6, and then I'm going to split the difference there. 0.045 would be halfway in between those two. So I think this is a z-score of 1.645 is what I would call it. Okay, let's go back to the notes. So I'm going to say z is 1.645, and we'll do the next one on StatCrunch so we could verify it. Okay, this next one says find the z-score that cuts off the highest 1%. So same idea, except now I'm looking for a z-score that cuts off the highest 1%. Well, that means I got 99% to the left. So if you're going to do it with a table, you would have to look up where's your area 99%. Again, because we only have left area reading. And if I'm going to do it on here, though, I can just say, okay, well, I don't know the score, but I do know I'm looking for area greater than, and the area I want is 0.01, 1%. So that would be a z-score of 2.33. Okay. Okay, and lastly, find the z-score that cuts off the farthest 5%. Well, this is a little tricky in the wording, but farthest 5% means that it could be on this side or this side. That's the furthest 5% of my data, and the trick is that both of these need to add up to a total of 5%. Together, they make 5% of the furthest data, because furthest could mean above or below the mean. So we have to account for both. If they both add up to 5%, then this has got to be 2.5%, and this has got to be 2.5%. Okay. Does that make sense to everybody? Combined together, they need to make up the furthest 5% of the data, which could be in either direction. Well, how I'm going to do this on StatCrunch is I'm just going to say, well, tell me this z-score. What z-score here? I mean, I could find either of these on StatCrunch easily, but what z-score there leaves 2.5% of area to the left. So let's go to StatCrunch, z-scores, so I'm standardized. I'll go ahead and put in left area. I don't know the z-score, but I know the area that I want to be left of is 2.5%, so that's 0.025. So that's the tail part I'm looking for, and it has a z-score of negative 1.96. Let's round it to. So this is negative 1.96. Now, by symmetry then, this has got to be positive 1.96. If I were to plug that into StatCrunch and look for that side, it would be positive 1.96. I don't have to do it because I know it's going to do it that way based on the symmetry. Oh boy, we're almost there, guys. We're almost there. Okay, let's try this example, and then we got the last page. It's a long video. Consider the normal distribution with mean of 15 and standard deviation of 2.5. Find the score that cuts off the lowest 10%. So we've got a normal distribution, we've got a mean of 15 and a standard deviation of 2.5, and we're looking for the score that cuts off the lowest 10%. So there's some score out here, and I'm using X, not Z. I'm not using Z because I'm not on a standard normal curve because that mean is not 0. But I'm trying to cut off the lowest 10%. Well, StatCrunch can tell me that value right away. Let's do it with StatCrunch. My mean is 15. They said my standard deviation was 2.5. Again, it's not standard normal. I don't know the score I'm trying to be, or that I'm looking for, but I know the area to the left of that score needs to be 10%. So that is a score of 11.8 if I round it to it, 11.8. Here, this X value equals 11.8. Right? It is below the mean. Okay. If I wanted to do it by hand, or with a Z table, well, what I could do is I could say, okay, let's assume that I normalized this thing. I could say, what Z score gives you an area left to be 10%? Right? I can find the Z score that gives me an area to the left to be 10%, and then I can convert the Z score back into a data value. I'll show you that. So let's find that Z score. It's a negative Z score, right? Because it's left of the mean. So let's go to the Z table. Let's find our negative Z score and look for an area of 10%. We did that, right? We happen to already do that one. What did we say that was? Negative 1.2. Oh yeah, I called it 8.5. We'll just go with that. Remember, that was where the area was 0.10. That's the score that we have area to the left being 10%. So I'm going to go with that one again, negative 1.285. This page. Oh, this page. Okay, so this Z score here is negative 1.285. That's the Z score that leaves 10% to the left. Now, if you remember how a Z score is found, it's your data value minus your mean over your standard deviation. Well, now I know the Z score, and they gave me the mean and the standard deviation. So if I plug those three things in, I can then go find that score X. I know the Z score. Don't know X, but I know the mean is 15 and the standard deviation is 2.5. And I could solve that equation for X. You know, I would just multiply both sides by 2.5 to get rid of the fraction. So what does that come out to be? 2.5 times negative 1.285. This is negative. This would be negative 3.2125 is equal to X minus 15. And then I'll just add 15 to both sides to get X. I got 11.78. which is pretty darn close to what StatCrunch told us, which was 11.8. In fact, I rounded this answer, so they might have been even closer. So again, what we're doing here is kind of the inverse idea. They're giving me area and I'm looking for the score. I want to be able to go both ways. Given the score, can we find the area left or right of that score? And given an area, can I find a score based on that area? Last page, and I'm going to skip that one because I'm tired. Let's do this last example here. It says the Gulfstream 100 is an executive jet that seats 6 and it has a doorway height of 51.6 inches. What percentage of adult males can fit through the door without bending? So they gave us, again, the heights for men is normally distributed with that mean and that standard deviation. So here's what I got. I've got a normal distribution. The mean height for men is 69.5 inches. Standard deviation of 2.4. And they say that the doorway on this jet is 51.6 inches. So they want to know what percentage of men, adult men, can walk through the door without bending. Without bending means that they are shorter than 51.6 inches. So let's say there's 51.6 inches. Anybody that is shorter than that can walk through the door without having to bend over, right? And anyone shorter would be left. It would be, smaller than that height. So I want to know what that area is. The long option is find the z-score. I mean, I can do it, right? I know the data value, the mean, and standard deviation, so I can find the z-score. And then I can consult my z-table and find that area. The faster way, which is what I'm going to do, is to use StatCrunch. So here I've got a mean of, they said 69.5 and a standard deviation of 2.4, and I want the area left of 51.6 inches. Now this, when they say e to the negative 14, what that means is it's 4.3 times 10 to the negative 14th power. What that means is, if you haven't dealt with scientific notation in a long time, is really it means that that decimal place should move 14 places to the left. So you would have 0.000000000043.812. That was 13 zeros. I counted them. All right. You basically have 0. Okay. There's basically no area to the left of that thing. So this is essentially 0. Not how I've drawn it, but I didn't draw it to scale at all. So the probability that adult male, or the percentage of adult males that can fit without bending, it is 0. 0% chance to happen, or essentially 0. Okay, so the last question, and I'm excited because this video was long. The last question says, for the same scenario, mean height of men is 69.5. What doorway height would allow 60% of the men to fit without bending? So what is the doorway height that's going to let 60% of men fit without bending? Let's think about where that height would be. That height wouldn't be here, okay? Because if the height was here, certainly couldn't anyone shorter than that height fit without bending. The only people, whatever this mystery doorway height is, that's going to let 60% of men walk through it without bending, whatever that magic number is, anyone shorter than that, yeah, they could walk through without bending. It'd be anyone taller that couldn't, right? They would have to bend over. Well, that's how I know that this magic mystery height wouldn't be here, because here's the 50% mark. This is where half of all men are. I'm trying to get 60% of all men to fit. This area is not 60, it's less than 50. So there's got to be some magic height here, some mystery height, I'll call it X, where I want 60% of the adult male population to be less than that height. And again, that's why I drew it to the right of the mean, because the mean is the cutoff for the halfway mark. So 50% of the men are left of the mean. I want 60% of the men to be less than this number so that they can walk through the door without having to bend over. You can do this with a z-score and a z-table, but I'm going to do it with StatCrunch. So in this case, again, they're giving me the area, but not the data value. Same mean, same standard deviation. I do not know the data value, but I know the area I want is 60%, 0.60. So, right, the mean would be right around here, the tallest point. So they drew it how I did, a little to the right of the mean. 70.1, they say, is the data value. So this data value here is 70.1. Okay, so a doorway height of 70.1 inches would allow 60% of adult males to fit through the door without bending. Okay. I hope this went all right for you. I know I'm going through this fast, but again, I'm hoping you're pausing, rewatching, working these out on your own. I promise you get a little time with these. It's always rough the first time you see it, but you get a little experience with this and they become very smooth, okay? So just hang in there, keep doing what you're doing, keep sticking with the material, and all will be well. Okay, talk to you guys later.